Hey guys, welcome to today's video. In this video, we are going to understand the breadth first search, that is BFS. So, what we have learned till now, so in the previous video, we have learned the graph representations, how we represent the graph, then how we are going to create the agency list. This we have learned, and the DFS, and how we are going to code for the DFS. And it is actually only three lines of code that we need to write it down. Now, in this video, we are going to move on to BFS. Okay, this is also one of the building blocks of the graph questions or the tree question. But in this video, we are going to understand breadth first search of a graph. So I have taken this the same graph which we have taken for the DFS. So now, if you see, so in this also we need to create the agency list. So that's why these concepts are very basic. So for all the graph questions we need to create a agency list. So in this graph we will see, like, let's take 0 as the starting node, and from 0 we are going to create an agency list. So we are going to create u, this is adj, okay, and the v's, so it will be a list. Okay, from 0, where and all we can go? From 0 we can go to 1, that is 1 and 2. Okay, so since it's a directed graph, so I'm following the arrow. Okay, if arrow is not present, then it means it's a non-directed graph, and we need to take both the ways. Like if 0 is going to 1, so if in the undirected graph this is one node and this is one node, so it means 0 is connected, 0 is going to 1 and 1 is also going to 0. But in our case it is a directed graph, so we are going to take only one way. Okay, from 0 we can go to 1 and 2. So I have written it like that. Okay, now from 1 we are going to 2. Okay, and nowhere else. Okay, so this is fine. Now from 3, sorry, from 2, we are going to 3 and 0. Okay, we are going to 0 and 3. Okay, now from node 3 we are going to nowhere else. Okay, so we have created our agency list, so our half of the work is done. Now we need to understand how it is different from the DFS. So DFS means depth first search. Like once you start from zeros, then you go to 2, then from 2 you go to 3. Okay, till you do not get any other nodes, you go to the end of the node. DFS, we go to the end of each node. That's why it is called depth first search. We are going to the depth. But this in this we are calling this as breadth first search. If you remember, for the tree also we create a BFS. How? We take a queue and we do a level order traversal, like this, then this. So each level we are traversing, right? So now in BFS also we are going to start from 0. Okay, we are going to take a queue. Okay, so we are taking a queue, so we'll add this first node over here. Okay, now since we have added here, we are going to take, since it's a graph, we understand, right? So we can end up into a cyclic graph as well, so we can end up into a cycle. So that's why we need to take an array called visited. Okay, which will keep track of the nodes if we have already visited or not. So in this case we have 4 nodes. Okay, 2 and 3. Okay, so now 0 we have added to the queue, so we will mark it as traversed. Okay, now we are going to see the child of 0. Okay, and then we are going to add it to the queue. So first we need to pop this. We are going to pop this. So we popped 0. Now we are going to see what are the neighbors of 0. So we can follow our agency list. So this is 0 and our neighbors are 1 and 2. So what we are going to do, we are going to add 1 and 2 to the queue. So let's add it. So I'm adding 1 and 2. So since we have added it, we are going to mark this as visited, 1 and 2. Okay, so we are going to mark 1 and 2 as visited. Okay, now we are going to take out 1. We are going to poll it. So 1. Now we are going to check who are the neighbors of 1. So the neighbors of 1 is 2. So but if you see here, 2 is already visited. Okay, since it's already in the queue, so 2 is already visited, so we are going to ignore this. Okay, now we are going to pop 2. Okay, so now we popped 2. So 2 is removed. Now we will see who are the neighbors of 2. So the neighbors of 2 is 0 and 3. Okay, so 0 is already visited, so we are going to ignore it. We are going to add 3. Okay, and we are going to mark this also as visited. Okay, now after removing, now we are going to see again in the queue. So 3 is present. Okay, now we are going to pop this as well, and 3. So we got the level order traversal like this: 0, 1, 2 and 3. Okay, so now if you come here, so you see first we visited this 0. Let me take some other color, blue. So we came over here, then from 1 we went to 1 and 2, and then from 2 to 3. So usually like the breadth first search happens like this. If this is the source, you need to walk it like this. So with every level, so it will be L1, this will be L2, this will be L3, and this will be L4. So it works like that. Okay, just the only difference between the tree and the graph is like we need to have this visited array so that we can detect a cycle. Okay, let's write the code for this. We are going to create a method called BFS. Okay, so we are going to use a list of integer. Okay, and it will be adj. Another one is the visited array. Okay, it should be a boolean. Now int source, which will be the starting node, and the number of indices if it will require. Let's see. Sorry. So we need to write the implementation of this. Okay, and yeah, one more thing I am missing is the result array. Okay, so where we are going to put our nodes. Let's name it as result. Okay, it should be a void. Okay, now what we are going, so first we are going to create a queue. Okay, queue of integer. Okay, let's name it as queue as new linked list. Okay, this is one. Now we are going to add our source. Okay, so in this case our source was 0, so 0 will be added. And since we have added to the queue, we know that, right? So whenever we will add to the queue, okay, whenever we are going to add to the queue, we are going to mark this as visited. Okay, so what we are going to do, so we are going to mark visited of source as true. Okay, now our queue has something. So what we are going to do, we are going to write similar to BFS of tree. We are going to write a while loop. Okay, not of queue is empty. So till our queue is empty, we are going to run this loop. Okay, so what we are going to do, we are going to pop our queue. So we are going to do queue dot poll. Okay, and this particular result we are going to add to our result. Okay, so now we are going to traverse all its neighbor like we said, right? So we are going to pop the each element and we are going to add its neighbor, and while we adding its neighbor, we are going to mark it as visited. Okay, so now for traversing the neighbor, we are going to use the for loop int v, and we are going to take all its neighbor of them. Okay, so this will give us all its neighbor. So now for all v's, we are going to check if it is not visited. Okay, then we are going to mark this as visited. Okay, once we marked it, we are going to add it to the queue. Okay, Now this is it. So we close this one, we close this bracket, and this close the method. Okay, so this is done, and our result here, we are going to have all the result. Okay, so this is it. This is the logic, and I think this is the same code which we have used for like trees. It is the same code other than this. So in this we had two child, we have multiple childs over here, and we are going to check whether these childs are already visited or not. Okay, so hope you understood the BFS, and if you have any questions you can comment down below, and in the next video we are going to write the implementation of this. Okay, see you in the next. Thank you.